I want to talk through the process because there's a lot of things in this one problem that can throw you off. The first thing for me that's important for us to do is kind of equalize the equation. In other words, I see fractions and I see non-fractions. And it's basically looking at the fact that I want everything in the equation to be a fraction to kind of equalize it. So the first thing I'm going to do is I'm just going to take that 1 and I'm going to rewrite it as 1 over 1. That makes it a fraction, and it makes it a little bit easier to work with. Now, the next thing I'm going to do is think about actually factoring any denominator that can be factored. And the reason for that is, yes, at this point, we probably could get a common denominator, but our common denominator might end up being something that's cubed, and that can make everything else tougher down the road. So I want to try and get that smallest common denominator, and to do so, I've got to factor. So first thing I'm going to do here is I'm going to factor that x squared plus 2x. And I'm going to rewrite this because I'm going to give myself a little bit more space. And x squared plus 2x has a GCF of x. So I can factor out that x. And then I've got something that isn't too bad to work with. So now I can start thinking about getting a common denominator. And the way I do this is I try to remember that to get a common denominator, every denominator has to be the same. So I start to look at, are there any factors that are already in common? And yeah, in the second two fractions, we see that x plus 2 as a common factor, but it's not part of that first fraction. So I'm going to multiply the first fraction by x plus 2 over x plus 2 so that now I have that factor. Now, the next part of this is I realize that, this x as a factor is only in that middle fraction, which means in order for us to have common denominators, we've got to have that x as a factor in both of the other two fractions as well. So I'm going to multiply everything by x over x. Okay, so at this point, let me rewrite what we have. So in the numerator of that first fraction, so we just have x times, I'm going to do this in the white there, x times x plus 2 over x times x plus 2. I mean, resist the urge here to make that 1, because I know most of you are like thinking in your head, that's a giant 1. You're right, it is. But if we make it a giant 1, we've just gone back to the beginning, and it really does us no good. So I'm going to leave that as it is for now, and then I'm going to have minus, and then the second fraction, which already had that common denominator, which was nice, and then equals, so you can multiply this out if you want to. It'd be negative x squared over, and then x times x plus 2. So now I've got it so that we have these three fractions that all have the same denominator. Now, some of you may have found a way to do this a lot faster where you don't do this next step and you just kind of skip to the what you'll see here in a minute. And that's fine, as long as you understand why you can do that. So what I'm doing here at this point is I want to get rid of all of my denominators. So to do that, I'm going to actually multiply everything by the common denominator. So that means every one of these fractions is going to get multiplied by x times x plus 2 over 1. And yes, I can do this because what I'm doing is I'm solving an equation and I'm multiplying everything in that equation by the same thing. So that's no different than if you were in the process of solving a really easy equation and you added something to both sides, or you subtracted something from both sides. So here I'm multiplying everything. I'm multiplying both sides by the same thing. And the nice thing about that, and the whole point of doing that, is to create those giant ones so that you can get rid of your denominators. I don't want to, try to start multiplying things out and then it just gets messy. Right here, I've got a giant 1. I've got another giant 1 right here. And then another giant 1 right here. That's the whole point. We want to get rid of the fractions. And by multiplying by the common denominator, we've done that. So what's left is just x times x plus 2 minus 4 equals negative x squared. Now, you can solve this equation. It's going to be a quadratic. I won't finish completely, but I'll kind of give you one more little maybe step here. We're going to have to solve by factoring. So in order to solve by factoring, you have to get one side of your equation to be 0. So I would add that x squared to both sides. So what I'm going to end up having to factor, yeah, let's go ahead and finish this one. We'll do this one the whole way through, and then we'll talk about another one, but we won't completely finish it. Is that. So what I like about this, what's kind of nice about this, is that it has a common factor of 2. So realistically, I could divide everything by 2. I mean, I'm allowed to do that. It's an equation. As long as I divide both sides by 2, I'm good. So if I divide everything by 2, including the 0, now it's a trinomial that's going to be a whole lot easier to factor. Was it x squared plus x minus 2? Let me do this on another page here. I'll put that back up there if you need it. And remember, I'm recording this, so you can always go back and watch it again. So I have this trinomial that I can factor. And I'm not going to spend a lot of time explaining how I can factor that, because I hope that one's pretty quick for you. We should be able to factor this as plus 2 minus 1, I believe. And then again, remember, your goal is to solve the equation. So this is just x equals 1 and x equals negative 2. I'm going to flip back to the other screen here in just a second, but I want you to understand something here. Well, I don't even know if I need to do that. Go back and look at the original problem. And I don't remember everything in the original problem. Is it x squared plus 2x or x squared minus 2x? Do you guys have it written down? I'll look back. All that I really care about here as I'm checking is what the denominators are. So I need to check my answers. This doesn't matter. That's why I'm not writing it down. I need to check these answers and plug them in and see if it gives me a 0 in any of my denominators. And if it does, then that solution doesn't work. So if I plug in negative 2, I'm going to get negative 2 plus 2, which is 0. So right away I can say, hey, negative 2, that doesn't work. I can't use that as a solution because it makes one of the denominators 0. If I plug in that 1 into both, so let's see, I'm going to get 1 squared plus 2 times 1, so that's 1 plus 2, that's 3. That's okay. And then I'm going to get 1 plus 2, which is also 3. That's okay. The only solution that works is 1. So it's really important that you actually are checking your answers, especially with that Delta Math assignment. You may have gotten 2 answers and put both of them in, and you didn't do anything wrong. It's just that one of them would give you something undefined.